Okay, 7-1 for Savas is understanding the likelihood and probability. So let's just talk about this for a second. You might want to pause eventually. But probability has to do with likelihood. It can tie into gambling and those sorts of things, whether or not something is going to occur. So we're going to read this, and it says, for a game show, Jared has to choose one of 8 boxes to win a prize. One of the boxes has the big prize, 3 boxes have a medium prize, 3 boxes have a smaller prize, and 1 box is empty. How confident should Jared be that whatever box he chooses, he will win a prize? Support your response with a mathematical argument. So take a few minutes and discuss this at your tables with your partners and see what you think. He wants to win a prize. Is it possible that, or likely that he's going to win a prize? So I am going to bet that the discussion that you guys had said, oh yeah, he's probably going to win. And here's how you prove this. This is all possibilities over winning. Now, the interesting part in this case that I find is that he's most likely to win, right? 1 box wins, 3 boxes win, 3 boxes also win. So if I add that, 1 plus 3 plus 3, those are all the ways that he can win out of 8. So he's got 7 out of 8 ways to win. And how do fractions work? You do the top number divided by the bottom number. And in this case, you are going to get 7 divided by 8, 8.875 thousandths, which, just to remind you, if we're converting that to a fraction, 100, or to a decimal, it needs 2 zeros. So 1 space, 2 space. So 87.5% he will win. That is most likely meaning he's going to win. All right, let's go to the next one. Use probability to describe chance. So this one has an actual picture of a spinner. It says, Elisa and Sherry spin the pointer to the right and record the color that it lands on. The table shows their results after 100 spins. How can Elisa and Sherry explain their results? Well, the best way, if it's out of 100, would be there was 23 out of 100 for red. Ooh, I could use my colors to match this. Red was 23 out of 100, or 0.23, or 23%. Yellow, you're going to have a hard time seeing yellow, so let's do black for yellow. 24 out of 100, or 0.24, or 24%. Green, 27 out of 100, or 0.27, or 27%. And blue is 26 out of 100, 0.26, and 26%. So just to make you realize these things, when you're looking at this, there are 4 pieces. So our total possibility is 4 out of all of them. Each color has 1 color. So that is what it goes down here. So outcomes are all the possible ways that what can come out of it, right? The probability is how often it happens. So those are the 2 words that we're going to talk about. Outcomes is everything that could happen. Probability is the amount out of our total. And that can be a fraction, or a decimal, or a percentage. Let's try it. How might this probability of a pointer landing on a given color change for the spinner shown at the right? So let's talk about how many total possibilities there are. 1, 2, 3, 4, 5, 6, 7, 8. So there's a total of 8, right? 8 pieces. Now they're 4 different colors, but because they're broken up differently, it needs to matter. So if I have blue, there's 2 out of 8. If I have red, there's 2 out of 8. If I have green, there's 2 out of 8. If I have yellow, it's 2 out of 8. If we use our calculators, that will be 0.25, 0.25, 0.25, 0.25. And some of you may even recognize that this can be reduced into or simplified into 1/4. So the probability of the pointer landing on a color, it doesn't really change based on the example above. Example number 2, use probability and likelihood to describe situations. We've been doing that the whole time. This time we have a dice. Now, in case you've never played with a dice has 6 different, I'm not doing a good job, different sides to it. Only one out of the side is a 2. So let's talk about this. That means my pen is not working. 1 out of 6, and they are writing that 3 different ways. 1 out of 6 or 1 out of 6. What is the probability that she will roll a number less than 7? So let's list the numbers that are less than 7. 1, 2, 3, 4, 5, 6. So our total possibilities of 6, and there are 6 different ways that we can have that happen. So 6 out of 6 or 100%. What is the probability that she will roll a number greater than 6? Well, that dice doesn't have anything greater than 6, so we have a 0 out of 6. 0 out of 6 or 0%. It's not possible. The game piece showed has 12 sides, labeled 1 to 12. What is the probability of rolling an 11? Well, how many 11s do we have on the dice? We have 1. How many possible sides are there? 12. So our probability is 1 out of 12. What is the probability of rolling a number greater than 5? Well, let's list all the numbers greater than 5. 6, 7, 8, 9, 10, 11, 12. And we'll count them. 1, 2, 3, 4, 5, 6, 7. So there are 7 numbers greater than 5 out of all 12. So it's 7 out of 12. What is the probability of rolling a number greater than 12? Well, there's not any numbers greater than 12. So 0 out of 12. Number 3, use probability to examine fairness. The probability of the spinner landing on A is 2 out of 6, which is equal to 1 out of 3. The probability of landing on B is 1 out of 6, or, well, that's not fair, is it? Well, if somebody picks B, they're going to win because they have more possibilities. So we have to decide if this is fair or not. And these are not fair because they're not equal. We can prove that. A is 2 out of 6. B is 1 out of 6. C is 1 out of 6. And E is 1 out of 6, right? 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5, 6. What did I miss? There's something that's 2. Oh, there's a D. 1 out of 6. So it's not fair because this one has more likelihood. Try it. Is the spinner shown a fair spinner? If yes, explain why. If not, describe a change that could make the spinner fair. So we should look at this. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's a total of 10. And our red has 4 out of 10. Our blue has 5 out of 10, and our white has 1 out of 10. If we take that and use our calculators, it'll 0.40, 0.50, 0.10. That means 40%, 50%, and 10%. So is this fair? Not fair. okay? Because 5 has the advantage. How could you make it fair? If you changed the white to red, then the probability is equal. Now, this is the first time that they started talking about finding the probability, whether or not it is impossible, unlikely, likely, or certain. So I would like to spend a little time talking about those things, but maybe not in this video. So we'll do some activities and do some talking about why this is fair or not fair, and how can we determine if something is impossible or if something is certain.